Students, this is Jayalakshmi of YK College of Engineering. Already we have started with that second unit introduction. Now we are going to discuss that ARM processor. The next topic in that one is LPC2148. Okay, here you are having that ARM architecture. The same ARM 7 is there with additional features. Okay, let me start with that one. The important features of this LPC2148 is it is having ARM 7 as a core processor with the bit size 32-bit and the RAM read-only memory inside this is 512 KB and random access memory is 40 KB. It is provided with 2 parallel ports and 2 32-bit timers with 4 capture and compare unit with 6 PWM channels, and it is provided with 22 interrupt sources, 1 watchdog timer, 1 real-time clock, 2 A to D converters, 1 D to A converter, and 2 I2C bus and 2 UA RTS and 2 SP and SSP bus and 1 USB ports. Okay, these are some special features. What's the difference between a common 8051 and LPC2148 is simply given here. That is 8051 is the core. But the additional features you are having that with the protected mode, you are having that LPC2148. This is a pin diagram of your LPC2148, and important features we can see that in detail. It is having 64 pin LQFP64 package, and we are having 32-bit ARM 7 TDMIS microcontroller inside this one. It is having the memory of 40 KB on-chip static RAM and 512 KB on-chip flash program memory in this one. The maximum speed up to 60 MHz operation, and it is provided with 2 D2A converters, 2 A to D converters, AD0 and AD1, and one single 10-bit D2A converter provides variable analog outputs, and it is having 2 timers, timer 0 and timer 1, each timer with the 4 capture and 4 compare channels with 6 PWM outputs and 1 watchdog timer. It is having 1 real-time clock also, low power real-time clock with the independent power and a dedicated 32 kHz clock input. And it is having serial bus interfaces protocol, I2C bus, 2 fast I2C bus with 400 kilobits per second is used here, and UART communication, 2 UARTs, UART0 and UART1 serial interface ports are there, buses are there, and 1 serial peripheral interface and synchronous serial ports are there. Then it is provided with general purpose IO up to 4.5 5 volt tolerant fast general purpose IO pins, 45 general purpose IO pins in this 64 pin package, and then it is having 22 interrupt sources with that 16 vector interrupt controllers. The speed of this one is 60 MHz CPU clock speed from programmable and chip PLL with setting time of 100 microseconds. These are all some important features. The oscillator, already we have discussed, on-chip integrated oscillator operates with an external crystal in range of 1 MHz to 30 MHz. Power saving mode, it is having idle mode and power down mode operations for saving the power, and CPU operating voltage is 3.0 to 3.6 volts with the 5 volt tolerant IO pads. Other important features in system, in application programming via on-chip bootloader software is there, USB 2.0 full speed compliant device, controller with the 2 KB endpoint random access memory. In addition to this, LPC2148 provides 8 KB on-chip RAM accessible to USB by DMA. Applications of this LPC2148 is, it is mostly used in industrial control, medical systems, access control, point of sale, communication gateway, embedded soft modem, general purpose applications too. That general architecture, bus architecture of your LPC2148. It is having local bus to connect the on-chip memory controllers and fast general purpose IOs, and it is having advanced high performance bus AHP for interrupt controller, and it is having VLSI peripheral bus VPB for other on-chip peripherals. AHB acts as a bridge for VPB, and VPB is mainly meant for connecting slower peripheral devices with a high-speed processor. This is the general architecture of your bus architecture of your ARM7, that is LPC2148 board. It is architecture is general ARM7 architecture with these additional facilities are provided with this one. The bus architecture, we have discussed that one. ARM7 has local buses to connect with the memories and the internal devices, and it is having a AHP and VPP, and your VPP acts as a bridge between that advanced high performance bus and the lower speed on chip peripherals. That is advanced high performance bus. ARM7 is connected with the AHP. This is the fastest bus in ARM7 core. It is connected with the vector interrupt controller and a bridge to second bus called the VLSI peripheral bus. Since the interrupt vector controller is responsible for managing all the device through interrupt sources, it is connected to the ARM7 core by the fastest bus. VLSI bus is another type of bus. All the user peripherals are connected to this VPP. Its acts as a bridge contains a clock divider, so VPP bus can be run at a slower speed than ARM7 core and AHP. What is the optimum speed of VPP? It is having 60 MHz crystal in this one, so it is having the same capability of running with that 60 MHz speed. And it is important to note that after reset, the VPP divider is set to divide down the AHP clock by 4. Okay, 1/4 of the clock frequency. Why VPP is operated in slow speeds? For two reasons. First, we have to connect the slow speed buses with the slow speed peripherals with your process. Since process speed is high, we have to connect it to the slow speed peripheral devices. Second, it gives Philips the option of adding slower peripherals to the LPC family without it becoming bottleneck on the AHP bus. Local buses, already we have started with that one. Next we are going to discuss with that special function registers in this one. Each underlying SFR is controlled by 3 user registers: set, clear and status registers. The most common mistake we have made is when you are using LPC2100 is to write 0 into the clear register, which has no effect. Okay, if you are writing 1 to the clear register, then it will clear the contents. If you are writing 1 to the set bit, then it will set the contents of the register to 1. Okay. Timers, next important topic is timer. LPC2148 has 2 functionally identical general purpose timer, timer 0 and timer 1. Both the timers are operating in 32-bit prescaler. This is timer allows us to generate precise time delay to blink the LEDs. Some applications are like that one. They can generate accurate time delay. How the timers are working in that microcontroller? Prescaled clock, prescale counter is used with the clock signals or an external clock. The counter is programmable with the 32-bit prescaler. Okay, so the tick rate of the timer counter is controlled by the 32-bit number returned in the prescaler register PR. There is a prescale counter which increments on each tick of the prescale clock. When it reaches to the value in the prescaler register, the timer count is incremented and the prescaler count is reset. On the next pulse. This causes the timer counter to increment on each pulses of this counter. Timer registers in the LPC2148 is prescale counter. The 32-bit prescale counter is a counter which is incremented to the value stored in the prescale register. When value in the prescale is reached, the TC is incremented and PC is cleared. The PC is observable and controllable through the bus interface. Prescale register, the 32-bit register which holds the maximum value of the prescale counter after which it resets. And timer counter, this 32-bit timer counter which gets incremented whenever the prescale counter value reaches its maximum value. Timer control register used to control the timer control function, that we will enable, disable the reset timer counter through this register only. Count control register. This register selects timer counter mode. In our example, we have used timer mode. This can be done by setting CTCR to 0. Okay, in timer mode, every rising clock preset clock edge on increment timer's prescale counter, or clear PC and increment timer counter. Next, PWM in LPC2148. Why we need that PWM? We all know that one microcontroller do everything with that timing. That means microcontroller works with the and it is operated in the range of voltage 3.3 to 0 volts as a digital 1 and 0. It cannot be produced, for example, 1 volt or 2.5 volt or any other value, different value than 0 and 3.3. Here PWM feature allows us to generate any voltage level between 0 to 3.3. So using this one, you can generate different voltage levels by using this duty scales. Here we have shown that one, what is the on period and off period of each clock cycle. We have given with that example 50%, 70%, 75% and 25% duty cycle. And you can calculate that duty cycle by on period divided by total time of on period plus time of off period. So with that, percentage of duty cycle can be calculated with that for PWM. Here in ARM LPC2148 we are having 6 PWM channels. They can be used singly or they can be double-edged, 3 double-edged PWM signals also. That PWM registers are PWM timer control registers, PWM prescale register, PWM match register 0 and match register up to 6. Okay, PWM match control register, PWM interrupt register, PWM latch enable register and PWM control registers. So with that we have completed all the topics related to that LPC2148. The instructions are same as that of your ARM7 instructions. Okay, in next class we will discuss about that Cortex M3. Thank you.